Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. My name is Nadia Disty with student ID 20243292 from class C. In this video, I will explain my machine learning practicum about the decision tree algorithm using the iris dataset. Okay, let's get started. The first step is importing all the required libraries. Here I import NumPy and Pandas for the data processing, Matplotlib and Seaborn for the data visualization, and several modules from scikit-learn, which are load iris to load the dataset, trend test split to the split data, decision tree classifier to build the model and evaluation functions such as accuracy score, classification report, confusion matrix, and confusion matrix display. After running this cell, the output confirmed that all libraries were successfully imported. In the second step, I load the iris dataset directly from scikit-learn using the load iris function, and the dataset is then converted into a pandas data frame for easier processing. I added two new columns, which are the species columns containing number 0, 1, and 2 as class codes, and the species name column containing the species name Setosa, versicolor, and virginica. From the output, we can see that the dataset has 150 rows and 6 columns. The third step is exploratory data analysis, or EDA, which is the process of exploring the dataset before building the model. First, I run the if info and the if describe statistic of dataset. From this, we can see that all columns are numeric and there are no missing values. Second, I check for missing values using the f is null. The results shows all columns have 0 missing values, meaning the dataset is already clean. Okay, third, I check the class distributions using value counts and visualize it as a bar chart. The result shows that each class has exactly 50 samples, which means the dataset is balanced. Fourth, I create a pair plot to see the relationship between features based on class. From the pair plot, we can see that the Sentosa class is very easily separated from the other two classes, while Versicolor and Virginica have a slight overlap. Fifth, I create a correlation heat map. From the heat map, we can see that the petal length and petal width have a very high correlation of 0.96, meaning they are strongly related to each other. The fourth step is pre-processing. Here I separate the dataset into X, which contains 4 features: sepal length, sepal width, petal length, and petal width. And Y, which contains the species class label. Since the iris dataset is already clean, no additional pre-processing such as normalization or encoding is needed. Okay, the fifth step is splitting the data into training and testing sets using the train test split function with an 18 to 20 ratio. The stratify Y parameter is used to ensure the proportion of each class remains balanced in both sets. As a result, from 150 total data, we get 120 training data and 30 testing data. The sixth step is building the decision tree model using decision tree classifier. I used the criterion parameter set to Gini to measure split quality and max depth of 4 to limit the depth of the tree and prevent overfitting, and random state of 42 to ensure consistent results. The model is then trained on the training data using the model fit function. The seventh step is model evaluation. The accuracy option on the training data is 99.17, and on the testing data is 93.33 present. The small difference between the two indicates that the model is not severely overfitting and is able to generalize well to new data. From the classification report, the Setosa class achieve a perfect precision recall and F1 score of 1.00, meaning all Setosa data were classified correctly. Meanwhile, the versicolor and Virginica classes each get a value of 0.90 for all three metrics, meaning there is one misclassified sample in each class. Precision measures how accurate the model's prediction are. Recall measures how many actual positive sample were correctly detected, and F1 score is the balance between the two. The final step is visualization. First, I display the decision tree visually. We can see that the root node uses the petal length feature with a threshold of 2.45 cm if the petal length is less than or equal to 0.45. The data is directly classified as Setosa over otherwise. The tree continues to the next branch to differentiate between versicolor and virginica. Second, I display the confusion matrix. From this matrix, we can see that Setosa was classified perfectly, while one versicolor sample was misclassified as virginica and one virginica sample was misclassified as versicolor. Third, I display the filter importance chart. From this chart, we can see that petal length has the highest contribution of around 0.57, followed by petal width at around 0.43. Meanwhile, sepal length and sepal width contribute almost nothing to the model's decision making. Okay, that concludes my explanation of the decision tree practicum using the iris dataset. In conclusion, the decision tree model successfully classified iris flower species with an accuracy of 93.33% on the testing data, with petal length and petal width being the most influential features. Thank you for watching. See you next time. Wassalamualaikum warahmatullahi wabarakatuh.